Most of what we're going to learn in this section is probably intuitive to you already. You're just not familiar with the terminology that we're using. And the best way to explain it is using a dice or a die. So, theoretical probability. I want to start by actually talking about what a sample space is. And a sample space is the total number of possibilities. Okay, so I said I was going to talk about a dice, or one die, and let's think about how many total possibilities there are on one dice. Well, there are 6 different possibilities, right? So if I said, what's the probability of getting a 3 on a die, you would probably say, well, that's 1 out of 6, because there's one way to get a 3, and the sample space is the total number of possibilities. So it's 1 out of 6. That's where we get that probability from. We could say, same with a coin. Okay, what's the probability of getting heads on a coin? Well, the sample space in this case is 2, because there's 2 options, heads or tails, and the number of ways of getting heads is 1. So theoretically, if I tossed a coin 50 times, how many times should I get heads? Well, you do 50 times a half, and that equals 25. So about 25 times out of 50 you should get heads. Now, we call this theoretical because that's only in theory what should happen. In likelihood, you might get 23 or 26 or maybe even 30 if you're a little bit unlucky. But this is just how to get the theoretical probability. Okay, in order to explain these terms, I think the easiest way is just to skip down to questions like this. And again, most of you could probably get this without even needing my help. So a point is chosen at random on this whole line. And we just said a second ago that the sample space is the total number of possibilities. And in this case, it's the total length. So to get the total length, just add everything up, 7 plus 13 plus 5, and we get 25. Okay, now to get the theoretical probability, we need to know the number of ways to get the desired result. In other words, how long is RS? Well, this right here is RS, and it's 5, so 5 out of 25, which actually simplifies to 1/5. So that was pretty easy. That was A. Okay, now how do we do a point not on QR? Well, not on QR, let's look at our picture here, and I'm going to go to a different color so that you can see a bit more clearly. Would you agree that not on QR is here or here? Alright, well, the total sample space, again, is 25, isn't it? Because that's all the possibilities. And how much of the line is not on QR? Well, it's 7 and 5, so that's 12 out of 25, and that doesn't simplify, so that's your answer. Now let's do C here. The point is on PQ and QR. Well, I don't like this question very much because PQ is right here, so this is PQ, and the question says what's the probability that the point is on that line and it's on that line. Well, it can't be on both, so the probability is actually 0 because there are 0 ways that that can happen. Hope you don't get tricked up by that one. Okay, pedestrian walk signal. So for 45 seconds it says walk, for 70 seconds it says don't walk. So we're going to use our same sample space and theoretical probability tricks here. So what's the probability that the signal will show walk when you arrive? So let's think about the total sample space. Well, the total is 45 plus 70, and that's hopefully that's 115. I'm doing that in my head. And the probability of it saying walk, well, that's this one right here, isn't it? So it's 45 out of 115, and that does simplify, and I'll leave you to do that in your own time. Okay, if you arrived at the signal 40 times, predict how many times you will have to wait more than 40 seconds. Well, for a regular geometry class, I think this is very silly. So I'm just going to cross that all out. But I do want to draw your attention to my previous discussion where I was talking about, if you remember me talking about the coins, let me just flip up here somewhere. Here we go. I said, okay, if the probability of getting heads is 1/2, how many times, if I flip a coin 50 times, how many times do you expect to get heads? Well, we got 25 by basically multiplying the number of coin flips by the probability, which was 1/2. So what about if I asked a similar question right here? And I said, if you walk up to the light signal, let's say 230 times, how many times would you expect to see the walk signal? Well, we're going to do the same thing. We're going to do the 230, which is the number of times, and we're going to multiply it by the probability of getting the desired result, which we just worked out was this. So that's 230 times 45 divided by 115. Let's see what the calculator gives us. And I got my answer to be 90 times, and that is correct. Okay, use the spinner to find the probability of each event. So let's start with A here. The pointer landing on 140 degrees. So remember our sample space? Well, in this case, the sample space is 360 degrees. So it's 140 over 360. And you've got to simplify that answer. I'll leave you to do that. Part B, 52 or 60. So that's saying, what's the probability of it landing in here or here? Well, in this case, you just add them together. So 52 plus 60 divided by 360, and again, that's got to be simplified. What about this? This is an interesting one. The word not is the key here, and most of you prefer to think of this as, well, not on 108 would be 360, which is all the way around, minus 108, and then divided by the total, which is 360, and that will give you your answer there. Okay, now let's do some area ones. So, find the probability that a point chosen at random will be inside the rectangle. Okay, find the probability that a point chosen at random inside the rectangle is inside the circle. Okay, so you're only allowed to be inside here. So let's do our total sample space first, okay? Well, the area of the whole thing is your 50 times 28, which we'll just do that in a calculator. 50 times 28, and that is 1400. So that's our total sample space. What are the chances of it being inside this circle right here? Well, the area of the circle is area equals pi times r squared, and pi times the radius, don't say that it's 18 because that's the diameter, it's 9 squared. So in the calculator that's going to give us 81 pi, so it's about 254.5. So you put that over your total sample space and you're going to get some decimal, which I'll let you complete. Okay, part B now asks you to do the same thing with a trapezoid. Again, the sample space is 1400, so it's over 1400, but now we have to find the area of the trapezoid. So that's all of this, isn't it? Well, that's base 1 plus base 2 times height over 2, and that's 34 plus 16 times by the height, which was 18, divided by 2. And for that, I'm getting 34 plus 16, enter, times that. So I'm getting 450. So again, we just put that on the top, and whatever that answer gives you is the final answer. Okay, part C, on one of the two squares is what that should say, is actually a typo. So let's have a look here. The two squares, well, that's here and here. So again, the total sample space is 1400, and the squares are 10 times 10, that's for one square, right, so that's 100, but there's two of those, so it's 200, so it's 200 over 1400, and of course that simplifies.